Open quietly. Hello, boys. Hello, girls. How are you? Good afternoon today. How are you doing? Hope you are fine. Hope you are good. Today we carry on with our math lesson, and then today we'll be looking at solving triangles. Looking at solving triangles. Be looking at areas, cosine, and their sine rule. Today we'll be looking at examining area rule, the sine rule, and the cosine rule when dealing with triangles. Okay, so before I carry on, again, my name is Abdul Jafaru Abdullahi, and then we'll be doing trigonometry, and then in the trigonometry, we'll be doing the area, sine, and the cosine rule. So at the end of today's lesson, we should be able to, one, solve problems relating to right angle triangles and other types of triangle. Obviously, we know there are several types of triangle. We have rectangle triangle, we have right angle triangle, we have isosceles triangle, scaling triangle, different types of triangles. So, and then we know with right angle triangle, only Pythagoras and the trig ratios are applicable in solving right angle triangle. Again, right angle triangle can be dealt with Pythagoras theorem and trig ratios. So problem relating to the right angle triangle can be solved using those two. But other type of triangles, how do we deal with them? How do we solve them? For example, if you have a scaling triangle, or we have an isosceles triangle, how do we solve, how do you deal with problems relating to such triangles? Okay, right. So now we're going to be able to do all those at the end of today's lesson. And then also we should be able to prove the sine rule. At the end of today's lesson, we should be able to prove the sine rule, because proving of sine rule is examinable. So as grade 11 learner, you should be able to know how to prove this sine rule. You can be asked to prove it in your exams. Okay. And then you should be able to solve problems using the sine rule. So you should be able to solve problems relating to triangles using the sine rule. Okay. So let's go ahead. So solution to triangles. We say in grade 10, the triangles we worked with were right angle triangles only. In grade 10, we only worked with right angle triangle. In grade 11, formulas will be developed to calculate the length of a side or the size of an angle in other type of triangle. So this rule we include, these formulas we include the sine rule, the area rule, the cosine rule. Okay, so we're saying in this case, we're looking at the sine rule, we're looking at the cosine rule and the area rule. Because before now, we are used to triangles that are only right, that have got one of the angle of 90 degrees, which are rectangle triangle. So we are familiar with those. So with rectangle triangle, we use the Pythagoras theorem, we use the trigonometric ratios, where we talk about the sine theta, the SOHCAHTOA basically. So, but this case, we'll be dealing with other type of triangles. So I want to see now how do we find the length of a side, how do we find angles in other type of triangles. But before we continue, we do a quick recap of what we learned in our previous grade. We do a quick recap of what we did in our previous grade. Okay. Right. Now, we'll be looking at this as an example. Example 1. In triangle ABC, triangle ABC is given with A as 90 degrees, angle C as 40 degrees, and BC as 12 centimeters. Determine the length of the side AB. Determine the length of the side AB. Triangle ABC is given with A 90 degree, C 40 degree, and BC is 12 centimeters. Determine the length of the side AB. Determine the length of the side AB. Okay, right. So to do this, so this here obviously is a right angle triangle because one of the angle is 90 degree. So the best thing to do is to sketch it, to have a sketch of it. So sketching it, we're going to have angle A as 90 degree, angle C as 40 degree, and then side BC 12 centimeter, and then determine the length of side AB. How do you find the length of side AB? So this here is a right angle triangle. So with a right angle triangle, we simply use Pythagoras theorem, or we can use our trigonometric ratios. Okay, again, the Pythagoras theorem, we can use the trigonometric ratios. So in this case, you can simply use the trigonometric ratios. The question mark, the AB being the what? Opposite angle, because this is our included angle. So AB be our opposite angle. Okay, AB be our opposite angle, and then 12 centimeter will be our hypotenuse, and then AC is our adjacent. So these are opposite, these are hypotenuse, these are our adjacent. So we're gonna need to find our AB now, our opposite angle, given our hypotenuse. Then you can use what? Sine. So you can say sine 40 degree equals to opposite over hypotenuse, and we cross multiply to find our opposite side. Okay. Okay, guys. Right. So from C, AB is the opposite side. So AC is the adjacent side and BC is the hypotenuse. So our trigonometric ratio says our sine C is AB over BC, our cos C equals to AC over BC, and our tan C is AB over AC. So we use what? Sine 40. Our sine 40 will be AB over 12. And then we cross multiply, so we're going to find our AB to be equal to 12 cos 12 sine 40. And AB equals to, if you punch your calculator, 12 sine 40 in two decimal places, you're going to get 7.71 centimeters. So our AB is 7.71 centimeters. So that we can get using the trigonometric ratios. And example 2 says, B part says, triangle ABC is given with angle A as 90 degree, angle C as 7.17 centimeters, and angle BC at 15 centimeters. Side BC 15 centimeters, side AC 7.1 centimeters, 7.71 centimeters, and then angle A is 90 degrees. Determine the size of C. Determine the size of angle C in the triangle ABC. So to better deal with this, we sketch the triangle to illustrate it. We label the triangle, and from there we can see how to solve for the unknown. So we first need to sketch the triangle ABC and label our angle A as 90, our side AC as 7.71 centimeters, our side BC as 15 centimeters, and then we need to determine the side C. Okay, so if you sketch that, you're going to have something like this. This is our triangle ABC with our AC 7.17 centimeters, our BC 15 centimeters, and then we have to find, and our angle A is 90 degrees, and then we have to find angle C. So of course, you can also use, because this is a rectangle triangle, you can also use our trigonometric ratios. You can use our trigonometric ratios. Okay, so what we're going to use here, this is our angle we're considering. Then AB be our opposite. Then AB is our opposite angle, adjacent angle, opposite side rather, adjacent side, and hypotenuse. So now we've got what? Adjacent, and we've got hypotenuse. So what trig ratio has adjacent hypotenuse is cos. So we say cos of question mark, cos of theta, call it question mark or theta, cos of theta equals to adjacent over hypotenuse. So cos theta equals to 7.71 centimeter divided by 15 centimeters. And then we're going to divide them with our calculator, and then find the cos inverse, the inverse of our answer to give us our C angle. Okay, so with trigonometric ratios, we can find our angle C. Using what? Cosine. The cos of theta equals to adjacent over hypotenuse. So divide 7,71 divided by 15, then find the inverse cos, the cos inverse of it, and then you get your answer. So basically we're saying cos C equals to 7,71 over 15, and then we try to find our cos C. So divide this here, and then find the cos inverse. You understand? And then to find your cos inverse, remember you point your shift and the cos. To find your cos inverse of your answer, whatever you get here, or you can punch cos inverse of this whole as it is, and then you're going to get 59,07 degrees. So our angle C will be, our angle C be 59,07 degree. Okay. Next. Now let's see now. So far we have done a refresh, a recap using, a body right angle triangle. We have seen right angle triangles. Now let's see other kind of triangles that are not right angle. How do we find the sides? How do we find angles? So to find angles for triangles that are not right angle, we use this sine rule, or we use the cosine rule, and then the area rule. Okay. So for the sine rule, so first of all, we need to know how to label our triangle. This here is a triangle. Obviously, the triangle. This is another triangle. So we say this triangle ABC. We label them triangle ABC. So this here is angle A, this angle B, this angle C. So we're saying the side facing angle A, the side facing angle A is the baby A. You call it the baby A, the small letter A. Okay, and then the side facing angle C, this is angle C. The side facing angle C is the baby C, the small letter C. And then the side facing this angle B. The angle is the capital, and then the side is the small letter, or the baby one. So this is angle B, this side B, baby C, baby B. Okay, so this angle B, baby our B. So this B, this is our small b, this is our C, angle C, this is our small c, and this angle A, this is our small a. So this is how we label our triangle. That's the first thing to know. So also, if you have got a triangle that looks like this is our A angle, automatically this is our side A. This is side facing your angle A. This is our angle C. So this will be our small letter C. This is side facing our angle C. Okay. And then here is our angle B. Up here is our angle B. So the side facing, we should learn that. Okay. Now, how does this work? So we are saying with triangles that are not right angle triangles, we use the sine rule. Use the sine rule. So what is the sine rule says? The sine rule says that in any triangle ABC, it is the fact, it has been proven, or we can prove that for every triangle ABC, we can prove that A over sine of A equals to B over sine of B equals to C over sine of angle C. Or sine of angle A over sine A over sine of angle B over side B equals to sine of angle C over side C. So this is called the sine rule. A over sine A equals to B over sine B equals to C over sine C. Or we can put it the other way. Sine A over A must be equals to sine B over B must be equals to sine C over C. So this is our sine rule. So we need to learn how to prove the sine rule. So sine rule is also examinable. Examinable means you can be asked in an exam to prove the sine rule, to prove that in a given triangle ABC, that if you have a triangle ABC, prove that the sine A over sine of the angle facing the A is equals to this another side B over sine of the angle B equals to C over sine of angle C, or this other way of, or this other form of it. Okay, so let's start with the proving. Let's see how to prove it. Okay, so to prove it, let's have a Cartesian plane. You draw your Cartesian plane, your y-axis and your x-axis. Okay, this is the y-axis and your x-axis, right? So from there now, you can create an acute angle. Just draw a line here, create a triangle, an acute type of triangle. an acute angle triangle. Just create a triangle from the origin, from this standard position, the origin here. Draw a triangle like this. Okay, create your triangle like this. Okay, so we say this is an acute angle triangle. Acute angle, right angle triangle. So draw your, we can prove the sine rule using an acute angle triangle or an obtuse angle triangle. Okay, this is when we are using an obtuse angle triangle. This is an acute angle triangle. Okay, acute angle means the two angles are smaller than 90. But obtuse angle, this another triangle, as we saw in the first, as you saw here, this here is an acute angle triangle. This is an obtuse angle triangle. Okay, so we can use either of them to prove the sine and the cosine rule. We can use either of them to prove the sine rule. You can be asked to use the acute angle triangle to prove the sine rule, or use an obtuse angle to prove the sine rule. So now we're going to use the two now. We want to consider the two. So using acute angle triangle and using obtuse angle triangle. Okay, so with the acute angle triangle, so from your origin, from a standard position, so sketch your acute angle and make a perpendicular h, the perpendicular height h. Okay, there is your h here. So which is perpendicular to the x-axis, make it 90 degrees here. After drawing a triangle, then you create this dotted line. With dotted line, create your h, which is the height perpendicular to this, to the x-axis, so 90 degrees here. Okay. Now, what do we do now? So now let's label our triangle now. So DAB, label this here as A. This is your point A, point B, and C. This angle A, angle B, and angle C of this triangle. So we are talking about triangle A, B, C. Okay, our triangle A, B, C, A, B, and C. Okay. Now, if this is A, if it's our angle A, automatically give you a small a. If we call this our B, since this is our B, then this side here of the triangle is our B. Okay, and then this is angle C, give you our small c, and then we create a perpendicular as height. Okay, so using the obtuse angle triangle to prove the sine rule, let's do it side by side using the obtuse angle triangle. The same thing we do, we create an obtuse angle around the standard position. We create an obtuse angle. Obtuse angle implies that what this angle here is more than 90 degrees. There's an obtuse angle here. So because this obtuse angle triangle, so we create it at the standard position, having sitting at this origin 0, 0. And can label it what? A, B, C. So this is our triangle A, B, C. Okay, so A here, this be our side A. B angle here, this be our side B. C angle here, this be our side C. Okay, now let's see the coordinates now. Let's talk about the coordinates. So what are the, so by A here now, go back to your acute angle. By A here now, the coordinates of this angle A will be what? 0, 0, because that's the origin. That's the standard position. So the coordinates of our A here is 0, 0. Meaning x is 0 here, y is 0. By point A. Okay. By point C, we're saying this side there, our triangle here is B. I mean, this side of our triangle is B. That means our coordinates of this point here will be B and 0. That means at the x value here, the x value at this point will be B and the y value will be 0. Okay, so our coordinate by C will be B, 0. This will be our coordinate for point C. Okay, because we're saying this length is what B. So from here to here is B. That means our B will be here. Okay, because here is our 0, so our B will be here. So the coordinate of here will be what? B and 0. Because we already said this whole length is B. I hope you understand that. Okay, now let's talk about the coordinate of B here now. The coordinate of this angle B here now. What will the coordinate at this point here? So find the coordinates here at this point, at this chapped point here, at this convex point here. So what do? We need to find the y and the x value. We need to find the y and the x value here. That's what we mean by the coordinate. What is the y value here? What is the x value here? Okay, what's the y value here? What is the x value here by point B? Okay, so to find that now, we need to now understand, we need to now try to, the y value here will be our h. Our y value will be our h. Our x value will be AD. Can put it as AD. Okay. we have it as what? AD. Okay. Now, so to now find our y value here now. To find our y value here, what do you do? You're going to say, use our sine rule, our SOHCAHTOA again. Use our SOHCAHTOA. So now we need to find our y value here. To find our y value here, our y value will be equals to, so take this one as your angle now. Look at this as your angle. Look at this, see this as a triangle here. See it as a triangle. So if this is a triangle, we're saying our h here is our h here is our y. The y value here is, we refer to what? The height h. The y value here, that means of our y value, remember our y value here is this c sine a, and our x value is c cos a. Okay, so how do you get the c sine a? How do you get the c cos a? So now we're saying our y value here is this height h. So let's try to find our y value here with this height h from this what is triangle. So consider this as your angle A now. So this is your angle A, here will be your opposite. There's the opposite, there's your hypotenuse. So opposite hypotenuse is sine. So sine A be what? Opposite h over hypotenuse c. Again, sine A. I'm looking at triangle ABD now. Sine A, sine of angle A, if this angle A, right? This is the opposite, this is your hypotenuse. Okay, so sine A is what? H. Sine A equals to h over c. So if sine A equals to h over c, so h equals to a sine A times c. So that's how we get sine A times c here. That will be c sine A. So our h will be c sine A if we cross multiply. Again, if sine A equals to h over c, h over c. So if you cross multiply, your h will be equals to what? C sine A. The c with time with sine A. The c at the bottom with time sine A. So we get what? So our h here will be what? C sine A, which is our y coordinate here. Right. Okay. And to find our s coordinate is to find this length OAD here. To find length AD. To find the length AD, what do we do? To find the length AD, what do we do? We say our length AD be adjacent. Still considering this triangle here. They be adjacent, they opposite, they hypotenuse. Okay, so it can be adjacent over hypotenuse. So AD over what? C equals to what? Cos A. So cos A equals to AD over C. So if you try and find AD, so your AD equals to C cos A. So that's why we have this coordinate here. So let's carry on with the proving of our sine rule. So we're saying to prove the sine rule, first construction. Place A in the standard position and drop a perpendicular line from B to the x-axis. So we're saying after sketching your triangle, we're looking at the acute angle one, have your y coordinates, y-axis, and your x-axis, and then draw your triangle. After drawing your triangle, then drop a perpendicular here H. Okay. After drawing a perpendicular, then if we consider AC to be the base, the y coordinate of B is the height. Therefore, H equals to C sine A. So now, what we're saying basically is after sketching this and dropping a perpendicular, then try to find the value of your H. Try to find H. So H equals to sine, like sine A equals to H over C. So H equals to C sine A. H equals to C sine A. I hope you do understand that. So because sine A here, these are angle A, these are opposite, these are adjacent. So sine is opposite over hypotenuse. So sine A equals to H over C. So H equals to C sine A. So we're going to find out what? H equals to C sine A. Okay, so we're going to get that what? H equals to C sine A. All right. Now let's look at C here now. Let's look at this other triangle, this other side of the triangle now. Let's see this other triangle CBD. So to find angle C now, let's consider this as angle C. So this angle C, our H is our opposite, and this is our hypotenuse. So sine C will be equal to, sine C will be opposite over hypotenuse. Sine C equals to opposite H over hypotenuse. So if you cross multiply, H will be equals to A sine C. So H equals to A sine C. Okay, so here we got that H equals to what? C sine A. Here we got that what? H, this same H, because the H is for this triangle, it's also for this other triangle. So for this triangle, we're saying H equals to C sine A, and here we're saying what? H equals to A sine C. All right. So you're going to get that H equals to C sine A at first, then H equals to A sine C. So label equation 1, label equation 2. And because the H is the same in both cases, for both triangles, this the right one and the left one, the H is the same. So you can equate what? C sine A to A sine C, because both of them are equal to H. You understand? So H here for this triangle, for this triangle here, H equals to C sine A. For this other triangle, H equals to A sine C. So both are equal, so we can equate the two together. So you say what? C sine A equals to A sine C. C sine A equals to A sine C. And then we can rearrange now. If you rearrange this expression, then you can have sine A over A equals to sine C over C. Okay, sine A over A equals to sine C over C. Okay, so that is the first part. So now we put half of the rule, of the sine rule. So now to get the other half of it, you can just rearrange. If you rearrange the labeling, maybe you put here now, if you put it as B, A, and C. So put there B, put here A, put here A, and put here C. So you're gonna get also there, that's what? That you're gonna find there that by placing either B or C in the standard position, that means at the origin, it can be proved that sine B over B equals to sine C over C, or sine A over A equals to sine B over B. By doing the same process, following the same process, we'll be able to prove that. So, and then we can generalize that what sine A over A equals to sine B over B equals to sine C over C. So this is the sine rule. Okay. So this is the sine rule. But in the applying sine rule, you must understand that we don't use the whole of the three. We don't use the three at the same time. Either we use this and this, or we use this and this, or we use this and this. So we don't use the three at the same time. Either we use these two. So basically, we must get what 4 stuff out of the 4 terms. We must have 3 in using the sine rule. In solving triangle the sine rule, we don't use A, B, C. We don't use the 3, or use only 2. Maybe sine A over A equals to sine B over B, and then we try and solve them, or sine B over B equals to sine C over C, and try and solve them. Okay. Now let's see how this works now. Let's see how this works now. Now, for example 3. In triangle ABC, A is 40 degrees, BC is 12, and AB is 15. In triangle ABC, there is a triangle ABC. ABC. In triangle ABC, A is 40, BC is 12, BC is 12, and AB is 15. AB is 15. Now determine the other angles. Determine the other angles of the triangle, assuming that C is an acute angle. Assuming that C is an acute angle, we must find determine the angles of the triangle. We must find this. We find this angle here, as well as these 2 angles, as also we also find the side as well. So now that's the question. Now again, the question is in triangle ABC, A is 40 degrees, BC is 12, and AB is 15. Determine the other angles of the triangle. Also, we can also find the side. So assume that C is an acute angle, triangle is an acute angle. Now, how do we do this now? So what is known here? What is known here is we have what? 2 sides and an included angle. Always remember in math, we use what we have to get what we need. We use what we have. Whenever you ask any question, you must check what are the things you have, what are the parameters you have, what are the values you have. So now, to find the other angles there, to find these other angles as we are asked by the question, so we need to check now what are the things we have. We got this side here, We got this side here, we got this. So we can now use our sine rule to find angle C. Because you can see what? A over sine A, that means 12 over sine 40 is equals to C 15 over sine C. Okay. So now because we have two sides now, so we say A 12 over sine 40 equals to the sides. Take the side first. Take the side first. I prefer to take the side first. I'm going to say 12 over sine 40 must be equals to 15 over sine C. And from there, I can find my C angle by cross multiplying. By cross multiplying, I can find my C angle. So again, A over sine A equals to C over sine C. So I'm only using A and C now. A 12 over sine 40 equals to C 15 over sine C. And from there, I can find my C by cross multiplying. Okay. So our sine rule says sine A over A equals sine B over B equals sine C over C. So we have that sine 40 over 12 is equals to sine B over B equals to sine C over C. So we can now use these two now, the A and the C, to put them together. So sine A, sine 40 over 12 equals to sine C over 15. Or you can do the reverse. You can say 12 over sine 40 equals to 15 over sine C. And then you cross multiply. You cross multiply. So 12 times sine C give you 12 sine C. 15 times sine 40 give you 15 sine 40. And then with your calculator, you divide both sides by 12. So sine C equals to 15 times 40, 15 sine 40 divided by 12. So we can punch this in your calculator. So sine C equals to 0.080348445 to be your sine C. And then to find your C, then you find the sine inverse of your answer here. So find the sine inverse of this will give you 53.43 degrees. That'll be your angle C. That'll be your angle C. Right. So our angle C is 53.46. Yeah. So, but we can as well find for cos, when you find your cos angle, so you must also subtract. We've been told that the C is an acute angle, so it's fine like this. You may not subtract from 180, but sometimes if you're doing sine, you can subtract from 180. So, but here now our C is 53.46, then it's fine, because we are told there that our C is an acute angle triangle. So the C is an acute angle triangle, so 53.46 is an acute angle, then it's fine. So our C basically is 56.4, 53.46 is our C. So 53.46 is our angle C. Now to find angle B now, we know these three angles must add up to 180. So to find our angle B, that is pretty easy. You say 180 minus these two angles. That gives you angle B. Okay, that is angle B. Okay, let's see another example there. Let's see another example. Determine the value of unknown in each case. Determine the value of unknown in each case. So in each case, what is the value of your unknown angles? So the same way, we're going to use our sine rule. So how do you find theta here? There's theta, there's beta. How do you find theta? How do you find beta? Given two known sides. So what do? We can use our sine rule. Whenever our triangle is not a right angle triangle, then we can use the sine rule. Whenever the triangle is not right angle triangle, you think of sine rule or cosine rule. But once it's a right angle triangle, then that's when you think about either Pythagoras theorem or trigonometric ratios. So here now, this is not a right angle triangle. So what can we do? We can say what? We use our sine rule. So how do we use our sine rule? Then you can say our 13 over sine 70 is equals to 10 over sine theta. And then from there, you can find our theta by cross multiplying, and then find the inverse, the sine inverse. And then find our beta. Once we get our theta, then you can find our beta. Once we have our theta, then you can find our beta. Again, how do you find our theta again? You start from the known one. We have a side here, a known side, and a known angle. So we start off with those. So say sine 70 over 13. Sine of the angle over the side, sine 70 over 13 must be equals to sine theta over 10. And then you cross multiply, you can find sine 10 the way we did. And find your sine 10, find the find your sine, find the sine inverse of your answer, you get your theta. Once you get your theta, then to find your beta is easy by subtracting both of these from 180, you get your beta. The beta you're able to get. And then to now find your side, that's also easy. Once you get your beta, once beta is found, you can easily find what x. Then you see what sine beta, because now you have beta now, sine beta over what? X equals to sine 70 over 13. And like that, you find your x. Again, after finding our theta, then with the theta, we find our beta. So once you have our beta, then you cannot find our x. How you find x again? You're going to say sine beta, whatever beta is, over x must be equals to sine 70 over 13. So if sine of beta over x equals to sine 70 over 13, you can cross multiply and find our x. So the same thing applies to b as well. So we to find theta here, we to find y, and to find x. So we're going to start off with which one? We start off with the one where we know a side and an angle. We have a side here, we have an angle here, so it's easier. So we start off with that. So we'll say sine 22 over sine 7. So sine 22 over 7, sine of the angle over the side. Sine 22 over 7 is equals to sine 114 over x. So out of 4 things, we have 3. We have sine 22 over 7 is equals to sine 114 over x. So we cross multiply and find our x. So, and then we, like that, we get our x. And for our theta is easy. 1, 2, 3 must give us 180, must add up to 180. Then you can see 180 minus 114 minus 22 will give us theta here. And then find our y. Once we have theta, then we can easily find our y. What do you find y? You say y over sine theta. Y over sine theta is equals to 7 over sine 22. Or you can say sine theta, whatever the theta is. Remember, you can get theta by subtracting these two from 180, get our theta. So sine of theta over x, over y rather, sine of theta over y is equals to sine of 22 over 7. From there, we cross multiply and find our y. And then to solve this one is a right angle triangle. You can simply use what? Trig ratio. We can as well use the sine rule. This one being what's 90 degree, this one being what's 15. Let's say what 15 over sine 90, or sine 90 over 15 is equals to sine theta over 12. And from there, you can find our theta. Again, sine 90 over 15. Sine of the angle over the side facing the angle, sine 90, because it's 90 degree, sine 90 over 15 is equals to sine theta over 12. So we cross multiply and then find our theta. So this is how we do, this is what we do in sine rule. So let's get to our textbook and practice more questions on this to have more information, to have more understanding of what you're saying. So thank you again for listening. We end our class today, and tomorrow we carry on with more revision of sine rule, and then we go to cosine rule. Thanks for attending and enjoy the rest of the day. Looking at our next class, we're looking at cosine rule. So join me tomorrow for the cosine rule lesson, and then enjoy the rest of the day.